Hello folks, this is my latest project, which is a weather forecaster using just a pressure sensor. In this case it's the ESP32 and an OLED display, 1.3 inch or 0.96 SH1106 or SSD 1306 driver chip. It uses Wi-Fi only for time services. There's no connection to whether underground or any other external data source, so you can play around with the forecasting rules for your particular location as well. Unit running, it's showing current time and date, air pressure and what the weather's doing over the next 3 hours. It's becoming clearer. Then it goes on to display a pressure trend, only a trend over the last 24 hours, is pressure rising or falling. And then it goes on to display a 1 hour forecast, which is a short-term forecast, and clear spells is the forecast outcome. Cycles round again. This is the first display category, which it shows you real time and date, current air pressure in hectopascal, whether the air pressure is rising or falling, and it has 6 different categories. And in this case it's rising at 0.6 hectopascal per 3 hours, and the forecast is sunny intervals or clear spells. That's the text version of the image, and some of those messages are quite long, but in this case it's a nice simple example. So there's a 3 hour and a 1 hour forecast, which is good for most eventualities. In this screen it shows you trend in air pressure, and its baseline is always hour zero, so all those pressure changes over the last 24 hours are relative to time zero or hour zero there. And generally air pressure doesn't change much, plus or minus 8 millibars is the standard used across the industry. And the 23 on the far left hand side denotes how long the display has been running. So if you've only just switched on, it would only be at 0 or 1 or 2 hours, so you get an idea of where the current data validity is. This is the connection diagram, an ESP32 or 8266 I2C bus connected to an OLED display and a Bosch pressure sensor, a BME 085 or the later 180 or the BME 280. This is how it operates, predicting weather using air pressure. So the rate of change of air pressure gives you a pretty good indication of what the weather's going to be doing. The greater the air pressure rate of change, the quicker. If it's rising rapidly, weather's going to get good. If it's falling rapidly, weather's going to get pretty bad, and it's usually storm force conditions. If it's steady, there's generally no change. I have a pressure graph here, which I took over a single day, and you'll note there is good correlation between minute drops in pressure and when rain occurred, which is testament to the science that when air pressure falls, it generally will rain. It does depend on temperature too, but in this forecaster I've ignored temperature, just using pressure only, and many weather stations only use pressure. So there it is. It's roughly 24-hour period, and it's showing every time it rains. The bottom chart is rainfall register from my weather station. I've got a semi-professional weather station, and it shows good correlation. But note, when the pressure drops, it doesn't always rain. So on that time base now, on the top chart I've shown temperature along the same rain time base, and on the previous chart when the pressure fell there was no rain, and that's because the temperature also dropped too. So it doesn't always correlate that when air pressure drops it rains. If the temperature rises or temperature falls, it can have an effect on whether or not there is some rain. But on balance, when pressure drops, it will rain in a very short time, and that's what the prediction in the algorithm is using. So here are the rules that are being used by the weather forecaster. Generally, if air pressure is greater than 1022 millibars, it will be good clear weather. And at the other end of the scale, at the bottom of the screen, if pressure is below 1009 millibars and rising fast, you'll get good clear cold weather. Or similarly, if it's falling fast, you'll get gales and heavy snow, and all the combinations therein. There are quite a few more rules in the source code, which you'll find on GitHub. I have good correlation with my own weather station, so I have confidence in the outcome. The air pressure you use needs to be adjusted for your particular location. Enjoy.